Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the January 2007 Core Mathematics C2 paper from Edexcel. It's a modified version of the actual question because I wanted to give my students a revision of how to sketch these functions. In the actual question, the graph is actually given to you. So it's a bit more involved now. Basically, we've got this curve, y equals x times x minus 1 times x minus 5. We have to use calculus to find the total area of the finite region, which is enclosed between the curve C and the x-axis and the line x equals 2. Okay, so we have to first of all think about how to draw this curve so we can picture what's happening and find, identify the areas that we need to find. So the first thing we have to do is try to think about what type of graph we are dealing with. And if you look at this, if you were to expand this, you would get x cubed as your highest power. It would be positive x cubed. So first of all, we identify the shape of the graph. So we can see that this is a cubic graph. A cubic graph which has a positive coefficient for x cubed, which has therefore this type of shape. So it's going to have this type of shape when we draw the graph. Okay, as opposed to this. This is when you have a positive x cubed coefficient. This is when you have a negative x cubed coefficient. So it's going to be like this, not like that. Right, so that's one thing. So we know that information. Secondly, we have to be able to see where does it cross the x-axis, where does it cross the y-axis. Now we know that a curve crosses the y-axis when x equals 0, because the y-axis, every point on it, x is 0. So we replace x with 0. When we replace x with 0, you have y equals 0, basically. You have 0 times minus 1 times minus 1, which is 0. So it goes through the origin, basically. And thirdly, we want to find where does this graph cross the x-axis, which is like the opposite. On the x-axis, y equals 0. So we're going to replace the y with 0. So we end up with this equation, x times x minus 1 times x minus 5 is equal to 0. So we can solve this because we have a product of factors equals 0. So one of those factors must be 0. So either x is 0 or x minus 1 is 0, in which case x equals 1. Or x minus 5 is 0, in which case x equals 5. So as we already determined, it goes through the origin, it goes through the point 1, 0, and it goes through the point 5, 0. So now we have all the information we need to be able to make a sketch of this curve. Okay, so if we sketch a curve such as this, then we know it's got this type of shape. So first thing I'm going to do is I'm going to just draw that shape. Okay, I'm going to draw that shape. Okay, so I'm going to draw a shape just like that. So let me just move this out of the way. So I'm not going to draw the axis first. I'm just going to draw a cubic curve of this type of nature. So it's going to go like up, down, something like that. Okay, not perfect, but not bad. All right. So now I know it crosses the x-axis in 3 places: the origin, 1, 0, and 5, 0. So the distance between these 2 points is 1, and between those 2 points is 4. So my x-axis, if I draw it, should be somewhere up here. Okay, because the distance between these 2 points, okay, is going to be more or less than the distance between those 2 points. So this is like 0, this is 1, and this is 5. Okay, so of course my y-axis goes through 0. Right, so that would be the y-axis. So you have your y-axis and you have your x-axis. Now, so it says here, enclosed between the curve C, the x-axis, and the line x equals 2. So I have to also draw the line x equals 2 here. X equals 2 is a vertical line which passes through the x-axis at 2. It's going to be something like this. Okay, so this is the line x equals 2. Is it straight? Okay, this is the line x equals 2. Make it a bit thicker. So this is the line x equals 2. So the area that we're looking for is the area between the curve and the x-axis, the area enclosed. Okay, so it's this area over here, and it's also this area over here up to x equals 2. If it didn't say and the line, if it just said between the curve C and the x-axis, we would continue shading all of that part as well. But in this case, they want us to stop where x equals 2, enclosed between those. So we got to find this area over here. That's the area that we have to find. Okay, and the equation of our curve, y equals x times x minus 1 times x minus 5. Okay, so now we need to find this area. Now, normally when you find an area under a curve, you integrate the expression, okay, with respect to x, and you put the limits. In this case, we would put 0 and 2, okay? But the problem is when part of the curve is on one side of the line, and the other curve is on the other side of the line, okay, in this case the x-axis, then what happens is one part of the area will be positive, the other will be negative. So I can't do this. Okay, in fact I should make this a bit more realistic. 2 should be a bit more as a proper sketch. Just make this a bit more realistic. Anyway, no problem. It's okay, that's fine. It's not really that well drawn, but you get the idea. That one should be a bit closer to here, really. Anyway, no problem. Okay, so if I did this, I'm going to basically find the difference between these two areas. Okay, so what I must do is I must go from 0 to 1. Okay, and then I add the area between 1 and 2. Now, the problem with the area between 1 and 2 is that it's below the x-axis. So if I put 2 and 1 here, this is going to come out as a negative area. It will be the same thing as, if I just took the integral between 0 and 2, it's going to give me the difference between those areas because part is positive, part is negative. So what I have to do is I have to either add the negative version of that, so then you're going to have negative and negative gives you positive, or I can say, okay, that part that's below the x-axis, I know that the area is going to be negative. If I take the limits of that and switch them around, if I take the limits of that and I switch them around, so instead of having 2 and 1, I put on the top 1 and the bottom 2. Okay, that will give me the area as a positive answer. So I'll just add these two areas together. So I can't go 0 to 2. It will find the difference between the areas. It won't add them together. I have to split it up into the parts. That section above, that section below. Okay, I must do that. So now we have got an idea of what to do. I'm going to just take this and expand it so that we don't have to keep doing the same thing again. So I have x times x minus 1 times x minus 5. When I expand it, I have x times x squared minus 6x plus 5, because you have x squared minus 5x minus x plus 5, which gives you x cubed minus 6x squared plus 5x. So now, if I integrate this, x cubed minus 6x squared plus 5x, if I integrate this with respect to x, I'm going to have x to the power 4 over 4 minus 6x cubed over 3 plus 5x squared over 2 plus c. Okay, so now because I have these definite integrals, I don't have to put plus c when I integrate them. I'm going to just put these now as x to the power 4 over 4 minus 2x cubed, because this 3 and the cancel out, plus 5x to the power of 2 over 2. Close bracket, and I put limits of 1 and 0, then put plus, same thing, because it's the same equation. So x to the power 4 over 4 minus 2x cubed plus 5x squared over 2. And I'll put the limits as 1 and 2 instead of 2 and 1. And that should give us the area that we require. So that's going to be a quarter minus 2, okay, plus 5 over 2, minus, I'll put 0 in there, that'll be 0, and I have plus, and then I'm going to have 1/4. Okay, it's going to be the same as this basically. So that's going to be 4 over 2, right? In fact, we can put it over 4. This is going to be 8 over 4. It's going to be plus 10 over 4. So you have 10 over 4 minus 8 over 4, which is 2 over 4. That's going to be plus 3/4. This will also be plus 3/4. Okay, and minus, I'm going to put 2 into here. Then the bracket, 2 to the power 4 is 16. 16 over 4 is 4, minus 2 times 8 is 16. And you're going to have 5 times 4, 20 over 2, which is plus 10. Okay, 20, that's 4, 5 times 4 over 2, 20 over, that's 10. Okay, that's that part done. So we're going to end up with 3/4 plus another 3/4. This gives you 3/4 plus another 3/4. And you're going to have minus, that's going to be 16, 4 plus 10, which is 14 minus 2. So you're going to get plus 2. So you end up with, that's 6 over 4 plus 2, which is 3 over 2 plus 2. 3 over 2 plus 2 is going to be 3.5, 3.5. 3.5 square units. Okay, so there's the answer, 3.5. Okay, so that completes this question. Okay, and that's, as I said, a question in my notes. Okay, other questions from this paper. Okay, January 2027. If I do ever answer any of them, I'll put them in the playlist that will appear at the top right of the screen. Other questions from integration of my P1 of Cambridge, you can find here. Of my P2 of Edexcel, you find here, because that's where this area in the graph comes in. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.